When you're solving with x's and exponents, the first thing you want to do is try to get the same bases, and then you can set the exponents equal to each other. But the problem is you can't always get the bases to be the same. For example, here we have 6 to the x equals 42. We can't possibly make either of those have the same base. So what we're gonna have to do is log both sides. But now because we have logs in the problem, we can expand this and bring the x down to the ground. Now we have x times log of 6 equals log of 42, and the x is no longer in an exponent. X is being multiplied by log of 6, so let's divide by log of 6 to both sides to get x by itself. So x equals log of 42 over log of 6. That would be your exact answer, or if you needed a decimal approximation, you could plug that into the calculator. Number 2, just like when you're solving for radicals, if there's one radical in the problem, you want to isolate it before getting rid of it. Here we have one thing to an exponent. We need to get it by itself first. Number 1, it was already by itself. So we can add 3 to both sides and divide by 4. Now it's by itself, so we can log both sides. Whenever you see an e in the problem, I would actually take the natural log of both sides. You're going to end up with the same answer, but your answer is just going to be cleaner if you're giving an exact answer. Now we can expand, so we can bring the x out front. And the reason our answer is going to be cleaner now is because natural log of e, that's the same as log base e of e, which is 1. So natural log of e, whenever you see that in the problem, you can change that to 1, which means x equals natural log of 2. Here we have 2 exponents with x's in them. Again, try to get the same bases first, but with an 8 and a 5, we're not going to be able to do that. So let's log both sides, either log or natural log. And remember, the purpose of logging both sides is so that we can expand and bring the exponents down. Now it's an algebra problem where we're trying to get x by itself. So the next thing you're going to always want to do is distribute. So that's 2x log 8 minus 5 log 8 equals x log 5 plus 1 log 5. Then you want terms with x's on one side together and terms without x's on one side together. So I'll bring this one over, I'll subtract it from both sides, and then I'll add this term over to both sides. Now we can't combine both of these, but we can factor out an x. So we're left with 2 log 8 from the first term, carry down the minus, and then we're left with a log 5 in the second term. And now because x is being multiplied by all that, we can divide by all that. So this would be your exact answer, or you could plug that all into the calculator to get a decimal approximation. Just make sure that this is all in parentheses and this is all in parentheses. But I know that was a lot of steps, but you'll see when you have x's and exponents like this, it's going to be the same steps every time. Log both sides, then expand by bringing the exponents down, then distribute everything that can be distributed. Then you get the terms with x's to one side, without x's to the other side, and the side that has the x's, you want to factor out an x, and then it's going to be multiplied by the rest, and that whole part you can divide over.